Hello, and welcome to this Excel tutorial on using bond market conventions, showing how we can apply this in an Excel spreadsheet. So first we're going to look at how we would do yield to maturity and price. So if we click on this, we will see what the inputs. We're using the Excel yield function, which is different from the TVM function. So this is taking actual dates, the maturity date and the settlement date. So the settlement date here is C8. We see the maturity date is C4 up here. And then we have rate, 4% in this case, in cell C5. C9 is the price expressed as a percent of face, but without the percent sign. The face value, or at redemption, 100. C6, we have the payment frequency, so 2, as it would be for a US Treasury bond. And then finally the basis, which is using basis code 1. And over here are the various basis codes. So the ones we'll use for the session are 0 and 1. 0 is the corporate convention. So that's 3360. 1 is for US Treasuries, and actually 4 is very similar to 0. 3360 as applied in Europe. And so we see when we use that function, we get a result, yield to maturity, 3.6442%. If we were to change, for example, the frequency to 1, then it would be treating this as a 4% annual bond, and it would be calculating the yield to maturity then on an annual bond basis. And we could change this to 0 to be a 3360 convention. And you see very small change, not much change in the decimal place over here. And then now let's look at price. So price is essentially doing the same thing. It's using exactly the same date, settlement, and maturity, rate, and we'll put as an input here yield. That we calculated before, and see if we get back the same price. Redemption is 100. Frequency is the same, 1 in this case, and then basis is 0. Okay, and we get back the same price as you'd expect. And of course, if we change these back to what they were before, we will still get that result. So pretty easy. So let's now move on to accrued interest. So here we have the same parameters that we had before: maturity date, coupon rate, payment frequency, the day count basis code over here, settlement date, and then the quoted clean price. And we want to calculate the accrued interest for this bond. So we're at the settlement date is in the middle of a period. It's a semi-annual bond, so the next coupon payment will be half of this rate times 100 to turn it into a dollar amount or percent of face. Then we need to know how long the period is, and we can use the Excel function called coup days, and it takes as inputs the settlement date, the maturity date, the frequency, and the basis. So using those inputs, it calculates 184 days in the coupon period that contains this settlement date. So that would be a date that goes from August 15th, 2018 to February 15th, 2019. And then the coupon days passed, we're using exactly the same parameters, but here there's an extra B, notice that in the function. So it's coupon day BS, and that returns the number of days that have passed. So then if we take the ratio of those and multiply them by the next coupon date, we can get the accrued interest. So it's 49 divided by 184 times 2, and that gives the accrued interest of 0.5326. And so then if we want to do that in one formula, we could do that quite easily. just basically combine these three cells. So this is calculating the next coupon payment. This is calculating the number of days passed, and this is calculating the number of days in the period. And we get the same result, 0.5326. And then we add the clean price and the accrued interest, and we get the full dirty price. And then finally, just to note here, we have another function that's sometimes useful if you want to show what the actual maturity is in years. Now, it'll be a fractional period because typically you'll be not on an even coupon date. So you can use the year frac function, and the inputs for that, the parameters for that are the start date, the end date, and then the basis. So it's going to be consistent with the same day count basis code. Okay, so let's move on now to price yield sensitivity. And here, these are the same parameters we had in the previous two examples. This is the same calculation of accrued interest that we did before, the full dirty price and the maturity in years. So those numbers should correspond to what we have there. And then this is the yield to maturity that we'd done in the first tab. So that's 3.64 using the yield function. And what we want to do is we want to calculate PVBP, modified duration, and Macaulay duration. So let's do it the traditional way, basically making a small change in the price. So we'll use the Excel price formula, and we're going to change the yield by 1 basis point divided by 100. That's right there. And then the other parameters are the same. So settlement, maturity, the rate, the coupon rate, and then this is the yield. So that's going to C14 here, and we're subtracting that small amount. This is the redemption amount, 100. That's the frequency, so 2 in this case. And then the basis. So once we've recalculated that, we can then subtract the price, C9, which is here. And then we have to multiply that result by 100, basically, because we didn't make a 1 basis point change. We made a 1/100th of a basis point change. Okay, so if we do that, we get the PVBP of 0.446. And this is for this bond with a fractional period, accrued interest, all of that. Now, modified duration, you have to be a little bit careful with this to know which price to use. And as it turns out, we'll use the dirty price. So we're taking the PVBP, so that's the change in price from a 1 basis point shift. We're dividing that by what we would pay, which is the full dirty price. And then we're dividing that by the yield shift, 1 basis point. And that comes up with 4.37. And then the Macaulay duration, we're using the relationship that we can take the modified duration and multiply it by 1 plus the yield over the frequency. So that's the yield, and then that's the frequency. And so that gives us the Macaulay duration. Now, there's another way of doing it. It turns out that Excel has some useful functions called duration and M duration. And as it turns out, duration is for the Macaulay duration, and M duration is for the Macaulay, and M duration is for modified. And so here we would just use the duration function, settlement date, maturity date, coupon rate, the yield, and the frequency, and the basis. So those are the parameters. And it returns the Macaulay duration of 4.45. And you note that's the same as we got there. And then for modified duration, we'll use the M duration function. And again, we're using the same parameters: settlement, maturity, coupon date, yield, frequency, and the basis code. And it gets the modified duration. And that's the same as we had up here. So 437 and 437. Now, Excel doesn't have a PVBP function, but it's quite easy to get that from the modified duration. So we can basically take 1 basis point times the modified duration. So that's going to give essentially the return on that 1 basis point, and then we multiply that by the dirty price, and that will give us the PVBP in price terms. And just to show us that we get the same answer as we did before, so that should give us confidence. So then finally, we can just show how these are applied. We can use the approximate method which is going to be graphed here with the orange line. And there, all we're doing is we're essentially taking the yield change here and multiplying it by the modified duration. We could take this one or this one, since we've calculated it twice. And then we copy that down for all these yield changes, and then that gives us the graph here. And that's the straight line, because remember, this is a linear approximation using duration. The other way we could do it is we could do it precisely. And here we would use the Excel price function. So this is exactly as we did before, but instead of doing a small change, we're going to use the actual change. So we're doing the plus I6 here, which is that. And then when we copy that down, that'll calculate the exact price change for that if we have to subtract the original price. So that's giving us the delta price. And then to convert that into a return, we just take that price change divided by, again, the dirty price. So that's a mistake you might easily make, thinking you would divide this by the clean price, but that's not what you've invested. You've invested the dirty price. So once we've done that, we've got the exact measure, and then so we can see that actually our approximation here is as good as it was when we looked at this using TVM functions. But now we've got the power to do this with much more realistic situations where we have bonds which are not going to exactly line up with even maturity dates. So here we have a maturity of 4.87 years, and everything works beautifully. So that's it. Thank you for listening.